So here's the final PWM generator circuit and how it ties to motor control. And this is the way and all the modifications I made from the first one. So the same basic principle is here. It starts out with this CD 4106 Schmidt trigger inverter, which generates through a diode here a sawtooth wave. And the modification I made is I had a 470 ohm resistor here, and if you put a 1 meg pot in the potentiometer here as the resistor to ground, you can adjust the frequency manually on the fly. The output of that gets taken from the input side, not the output side. Gets put through an input buffer centered to ground with this capacitor resistor combo, that signal goes through to the non-inverting input of a comparator. The reference voltage is for that comparator is basically, there's a switch mode. You could put an external control voltage input, so whatever voltage gets input through the control voltage is the reference voltage, and so this goes positive or negative based on that. Mostly I use manual, and so manual is just 100K potentiometer between positive 12 volts and negative 12 volt rails, so it gives you a 24 volt sweep, and that signal gets decreased to positive and negative 2 volt from this big sweep with this voltage divider, and that basically goes in as your reference voltage. So you can set your reference voltage to anywhere, and wherever that sawtooth wave goes above the reference voltage, it gives you a positive signal, and wherever it goes below, it gives you a negative signal. The other CV input that you see in my videos, I have a triangle wave oscillator that goes between positive and negative 1.5 volts basically, and it's just a low frequency oscillator. I use the same CD40106 inverting Schmidt trigger, and what I do is instead of a diode here, I put a 470K resistor to make it go slow, and a 10 microfarad capacitor that gives you a very low frequency oscillator, and then I put it through a 0.22 microfarad capacitor and resistor to ground to center the signal around the 0 volt line, and that gets put in, and it gives you a triangle wave that sort of fluctuates the reference voltage to the comparator slowly. The output of the comparator gives negative and positive voltage values, so the diode to ground backwards gets rid of the negative voltage. This divides it down by 50%, so you get the signal, PWM signal between 6 volts and ground. Then it gets buffered in a 1K resistor as an output here, and that goes through, that's the PWM output. That output gets connected to the MOSFET. So that's the gating signal of the MOSFET. And so the third modification I made here is that instead of putting the motor control on the source side, I put it on the drain side, which has its own advantages. And so here's the H bridge connected to positive. These are your switches for the H bridge. So these two are tied together, these two are tied together on the big switch that I have. There is a flyback diode to prevent the negative voltage bursts from the inductive effect of the motor, and that gets put into the drain. And so there's never any positive input if the motor is off, if any of these upper switches are off. So the MOSFET doesn't get hot, and very low amperage goes through there, and the source just gets connected to ground. And that is the final motor driver circuit with the PWM generator that I built.